Hi everyone, I'm Cheryl. When a particle is moving at a variable speed, it turns out that the velocity vector and the acceleration vector are not necessarily perpendicular to each other. So when we look for acceleration, we oftentimes want to talk about the tangential component as well as the normal component. These components are parallel to the tangent vector and the normal vector, which are perpendicular. So for this particular problem, we have a particle moving along the path e to the ti plus e to the minus 2tj. And we want to find the tangential and the normal components of the acceleration. So first of all, let's go ahead and find the velocity vector. The velocity vector is r prime of t, which in this case will be e to the ti minus 2e to the minus 2t times my vector j. The acceleration vector is the second derivative of my position, which is the first derivative of my velocity. So that will be e to the ti plus 4e to the minus 2tj. Now this is the vector that I want to find the tangential and normal components of. Okay, so to find the tangential component of acceleration, we want to take the acceleration vector dotted with the unit tangent vector. And another way of writing that is taking the dot product of v and a and dividing by the norm of v. So let's go ahead and do that. I have my velocity and my acceleration vectors right here, so I want to take their dot product, which means I'm going to take the sum of the product of their components. So I have e to the t times e to the t. So that's e to the 2t plus negative 2e to the minus 2t and 4e to the minus 2t. So that's going to be minus 8 times e to the minus 4t. And then we're going to divide that by the norm of v, which is going to be the square root of the sum of the squares. So that'll be e to the 2t plus 4e to the minus 4t. Okay, so that is my tangential component of acceleration at any point. I want to know what happens when t equals 0. So at that point, my tangential component is going to be e to the 0 minus 8 times e to the 0 all over the square root of e to the 0 plus 4e to the 0, because every time I plug a 0 in for t, it's going to turn all of those exponents into zeros. Now remember what e to the 0 is. E to the 0 equals 1. So I end up with 1 minus 8 all over the square root of 1 plus 4, or a minus 7 all over the square root of 5. And then that's the tangential component of acceleration. Now we're ready to move on to the normal component. So for the normal component of acceleration, we're going to take the dot product of acceleration and the normal vector. All right, so the first thing I need to do is figure out what that cross product is. So let's do a little side work here. The cross product, if you remember, you'll have your I, j, and k. The velocity vector is e to the t and minus 2e to the t. Minus 2e to the minus 2t and 0. For our acceleration vector, we're going to have e to the t and 4e to the minus 2t and 0. Okay, so when I do the cross product, remember I start with I and I eliminate the column with I and the row with I. And I look at the determinant here. Well, that's just going to be a 0. So my I component is 0. The j component, when I take out the column with j and the row with j, again, I'm going to get 0 minus 0. So I get 0 again. For k, I'm going to eliminate row k and column k, and I'll have 4 e to the minus t minus a negative 2 e to the minus t. And remember, that's all times my vector k. And that will reduce to 6e to the minus t times my vector k. All right, so that was my side work. Now let's go back to the formula. I want the norm of this vector. Okay, so I'm going to take the square root of this term squared. So that'll be 36e to the minus 2t. And then I'm going to divide that by the norm of v. I've already calculated that once before. So this is the square root of e to the 2t plus 4e to the minus 4t. All right, so that's my normal component at any point. I want to know what happens when t equals 0. So when t equals 0, my normal component is going to be the square root of 36 times e to the 0 divided by e to the 0 plus 4 e to the 0. Again, every time I plug in a t, all of those exponents are going to become zeros. E to the 0 is 1, so I end up with the square root of 36 all over the square root of 1 plus 4, which is 6 all over the square root of 5. And now you have your normal component of acceleration. I hope that was helpful. Thanks.